It is Thursday, November 24th, 2016, and welcome to this episode of Code Evolution. First of all, happy Thanksgiving to everybody. Hope you have a great holiday. So last night I was really inspired to kind of invest some time and energy into neural networks and really look at some of what's out there and available for people to kind of toy around with. And one of the libraries I came across was ConvNet JS, which has some great demos, and you can actually look it up on just type in, I think, ConvNet JS in GitHub, and it'll come up, and there'll be links to demos that you can actually look at. Again, it's running in JavaScript in the browser, which is kind of nice just to get an immediate kind of feedback. There's obviously plenty of different machine learning blocks of code that you could probably run in a more efficient, like in C or something like that. But for kind of learning, I really feel like doing things in TypeScript and in JavaScript is kind of nice, because you can really kind of you just get a little loose and try different things out. So in me doing that, I ended up kind of like I did with the 2048 video, I ended up refactoring this library and putting some time and energy into converting it over to TypeScript and kind of giving it a better architecture API, because although the amount of work that went into this lib is impressive, it looks as if it was kind of at some point pseudo abandoned or hasn't been up to date in quite a while, and it was more of an experiment versus actually kind of spending a lot of time to make an actual API that is highly reusable. So that's what I want to do. I wanted to make it better and kind of flex the muscle a little bit and try out some different concepts. So what I'm showing you here, and this is one of the API goodies that I want to review and hopefully get some feedback. I really want to hear what people think, because it's the idea behind literals as an application of being able to apply types to them and use them as constraints is really new as far as I know. I admit maybe there's some computer science guy that's like, I've been using, back in COBOL days, we used to do this all the time. And I'm like, I don't know what you mean by that. So, I mean, all I know is that string literals have really kind of, and also other literals. Now you can do Booleans, you can do numbers as literals, which is also really cool. But being able to define a type that equals a string is huge, because, we might pass around strings in JSON world that define, hey, this needs to be this specific value, and essentially to identify it, like some sort of type passing around. And this is a perfect example of that. In this neural network, ConvJS, they have different layer types, and you can see them here, all the way from softmax down to, local response normalization. And so what I did was, I've been following this pattern, and it's a little bit controversial. So if people feel like this is the wrong way to do things, I want to know what people's opinions are. So please comment. And that is, so I've named the naming convention I've been using in other cases when I have a group of different strings or literals in one is I'll use first of all I'll export it as a module. That way it groups them together into one thing. So if I go over to any one of my actual layers, when I actually go to type these out, all I have to do is type, for example, like if I remove this type declaration here, and I'll show you that if I was to type out this and say, hey, my layer type is layer type value dot max out, as you can see, WebStorm automatically identified this as its own import, and it automatically imported it and brought it in. And then obviously having it to be able to group it together is kind of nice, right? Instead of having to type max out, type layer, and like always repeating over and over the same part of the type. This is just a nice grouping mechanism, right? So that's one thing, is having them in their own, having a module with all of them grouped together as that module. You could, for example, which I've done before as well, is these could all be at the root of this module, but then you'd have to it wouldn't actually import as easy as what you just saw. If you were to have like, sure, you could say max out, and then it would just end up being max out. But I kind of like this when you're using this type of thing over and over and over again. Sometimes it's better to have it as a group together, and essentially like a namespace kind of, type thing, right? Now, with these types declared, we also have to have another type that I've kind of been declaring as in appending to this module is one that includes all of them. So when you go to, for example, one of these base classes that I made, like we'll go to layer base, you'll see that layer base, the first parameter takes the layer type, but of any one of them, right? That's what we expect. It needs to be one of those layers. And that's the nice thing, is that this is constraining, but not over constraining, right? It allows for the set of different layer types available, which is also really cool. Now the next part of this kind of string little thing, and again, really looking for feedback, hopefully, and seeing what people think, because I think this is pretty cool, is having the actual constants and then mapping those constants to their individual literal types. And I'm pretty sure someone's gonna think to themselves, like, you don't really need to do this. In many different ways, you could say you don't need to do any of this, right? But I'm kind of, I don't want to say that I'm old school, but I kind of believe in the whole thing behind constants. I think constants are important because if you have, again, a larger application where maybe for some reason you change a string, this will propagate throughout your entire application. And it's kind of nice for refactoring because it's just easier. As well as you could argue, and I've had back and forth, people say that, strings as immutable string objects being redeclared, that's an old notion of that if you have a new string, it's a new string. It's another, essentially a copy of it. And every time you add to it, you're creating a new object. Having constants avoids that. But again, it's probably not even something to worry about in being susceptible in modern compilers. I think that's kind of negated. But I still kind of follow that pattern, and I like constants. So there it is. So there's two things. We've got our layer type value, okay? And we've got our layer type. Now, why am I naming it this way? You might be thinking, like, it seems backwards, right? I've struggled with this over and over and over again. And in different cases, I have other groups of literals that I use where I'm following the same pattern. And I've tried both of them, both different ways. And what I find is that when you're talking about a type as a type, then you're really saying, especially when it comes to literals, it's a value of that type. Like it's basically, you could say layer type string could be the same thing, right? You could say layer type string is of this, right? Because when you go to actually consume this, and we'll go back to like max out, for example, because I haven't actually done this. When actually using these values as a normal, like consumer of this code base, you probably are going to actually go layer type, and then most of the time you're not defining the types, you're consuming them, right? So it's more convenient for the consumer to have essentially a shorter, more a name that you're not thinking about that there's a constraint on this. You're just going, yeah, I want the max out type, which is a string, right? It's not an ethereal type thing. It's just a string. So if I want to constrain something, then I have to say it can only be of this layer type value called max out, right? Now, I don't know if people understand what I'm saying here, but it is something to consider and thinking about when you actually start doing this. If you do start creating a pattern of grouping these together in a module and then having constants, you're going to find that I just kept going back and forth. How should I name these? And what I found was, I think this was the right way to do it, is have a distinction between the two. One is the layer type, which is the constants, and the other one is layer type value, which is type, which seems, again, backwards. For some, even my brain kind of like doesn't seem to make sense in some respects. But when I go to apply it, when I go to use it, it starts to make more sense. It's like, oh, well, of course you would do it that way. And even though I've gone back and forth, I end up reverting back to this pattern of an naming convention. So that's string literal stuff. That's the goodies for string literals. What else have I been doing that is another goodies? So somewhat related is the notion of kind of grouping things together. And, in module structure in JavaScript, in modern JavaScript and TypeScript, what you've got is this idea behind how do you break things apart and how do you group them together at the same time. You definitely want to have unique classes in their own, having their own file. This is, it seems pretty natural and normal for most people, is to not over group things into files. But then at the same time, you kind of want to be able to have namespaces, right? You want to have groupings of classes. And so you'll see this in, I think I first saw this used in Angular 2 when I was looking at the code base. And what you'll see is that there'll be files like an index. So for example, under this layers folder, there's an index here. And inside this index is essentially, well, it's some kind of useful things. First of all, I need to import them all because I have this registry that is being used by this function called new from type. So it's an easy way for me to kind of shortcut and say, if I pass you a string and only one of the allowed values of that string and some options, give me back the type from that. Give me back a new version of that, essentially like a factory based upon those values, right? And it uses this type registry to kind of look it up and then return it. It's kind of a simple little utility. It's great. But the other notion about having this index is being able to take and export again all of those types out to the world so that they can use it. There's another one I need to add in. And so by having this export, that way, if I'm going to use this, if I'm going to be using these types, and I'll show you an example of this. Now, originally the code here was using this term global, so it was injecting all of these different types into the global. All I did was, when I refactored it, I said, fine, I'm just going to create the index, and I'm going to group them all together. So we're going to actually go as a refactor, rename, and call these layers. There we go. All right. So now, the cool thing is that I'm only doing one import here for all of the layers. And I can do layers dot and then get the individual layers, which is, again, nicely convenient. And it's not up to me how to consume it. That's another nice thing, is that by providing this index, I give people two ways of consumption. You can pull them all in as one, like this. Or if I wanted to pull in a specific layer, I can still do, new fully. Well, let's do dropout layer. Okay, and I can get that type anyway, right? And it'll give me both, which is fine. There's nothing wrong with that. It's just a matter of convenience to the consumer, convenience to the person actually consuming the code. Or writing, right? And I found, that this seems to be a nice pattern to follow. And again, don't overdo it. Think about what you're doing. Like, for example, having this index is kind of nice for layers, right? Now, what I'm going to end up doing to kind of follow the convention here, I will take ConvNet and actually have, you'll see here, I'm going to end up having an index for it as well. Here it is here. And I'm slowly, progressively building this index so that I can import the entire ConvNet namespace and treat it as one. So when I read it, I know the distinctions between individual classes, which is kind of cool. Now, here's kind of the interesting thing to note as well. So, like window, for example, is one of the classes that was defined in ConvNet. Well, that's kind of a sketchy one because, right, we already know that there's a window type, all right, in the browser. But by exporting it out to ConvNet, I can then consume it later as convnet.window. That way, there's no confusion. And in fact, I think there is an example of this somewhere here. Yeah, there we go. So yeah, instead of having it be just window, I can say it's a ConvNet window, which is just, again, a nice convenient way to see a namespace or package, however you want to call it, and have it be grouped together. So it's very nice. And then also, what's cool is, remember you can have indexes within indexes. And so now I'm having this, I could type, for example, we'll go back to our code block here, because I've imported ConvNet here like this. I can do things like, I want to do, let's say const x equals new ConvNet dot layers dot dropout layer, right? Now that's something that, again, this is kind of taboo for people in JavaScript, because you don't really need to be doing this, right? If you're slick, you just kind of import the layer directly, and you can name it however you want, or you give it a unique name. But depending on the person, this can be inconvenient. And then again, what if the names are repeated in a way that collide with others? This is a way of preventing collision, because now you can essentially have it a prefixed namespace. So that was, goodie number 2, right? Is being able to define modules in a happy structure that, over time you're going to find, I think, will help out. So the last one I want to go over is one that is unique to what I was working on here, but I thought it was interesting. It was saving me a lot of time, and it also seemed to make a lot of sense from an API perspective. So we're going to look at our little dropout layer here. And so the first thing you're going to see is that there's this class called dropout layer. Now, dropout layer, the pattern that you're going to see is every layer has a layer type. And every layer not only has a layer type, it also takes a set of options, okay, that may be unique to it. And you can see this in kind of go to our layer base class that I have. So it takes a layer type, it takes a set of parameters, it has some, default properties, and then it always has a to and from JSON call. And for all of them, the to and from JSON call will actually have these values be translated every time. So I set up this base class to do the majority of the work. But the interesting part about that is that the to and from JSON will be unique in a sense that the input and output values are going to be a specific type. So I had to do, without going too deep into how I made these generics happy, which takes a minute of like toying with. Basically, I've got this interface that says I can do to JSON and I can do from JSON. But there again, each one is going to be unique. So I had to create a type parameter here that says, all right, well, you're going to need to provide the type that you expect it to emit from to JSON, and that same type needs to be the one that you do from JSON for that particular layer, right? Now, if we go back to our dropout here, so then when creating a new layer, what I ended up doing was saying, hey, I'm gonna specify essentially what the to JSON value type is, and then I'll also define the options. But originally I was writing out the interface. I was like, interface, dropout layer options, right? And then I would manually put it all in, and then I would use that and kind of go from there, and I would export it. But it started over and over. I'm basically doing the same pattern over and over. And it also seemed kind of lame that I had to keep typing the name over and over as well. So what I came up with is this, so you can you can essentially create subclasses and subinterfaces in TypeScript by declaring a module that matches, and this is after you've defined the class, that matches the name of the class. So I'm essentially statically extending this class to have some types on it. Now again, they aren't real, they're interfaces, right? So there is no such thing in JavaScript as these things. They don't exist. But it is useful in TypeScript that I can just go, instead of being dropout layer JSON, I can do dropout layer dot JSON, right? Or dropout layer dot options, right? Because these, but again, these are unique to this. So why is this cool? Well, what I was doing was I would just copy, and I would go to another one, like we'll go to, I think, where's max out here? We'll go to max out, right? And I would just paste it here, and then then I have this interface called unique, And all I would have to do for the majority of these was just replace the unique values with what's unique to that class, and then it would apply properly. I'd even have like implements the unique properties, and then it would show up, right? Which is really nice because I could define the interface, and then I could do the whole, in WebStorm, you can do generate and implement fields, but there aren't any, they're all implemented, so it's not going to tell me what to do about doing anything. But so here we go. If you can see here, the options are going to inherit from unique, so that includes this. And then the layer in is specific to how options work, because a lot of times you'll get these in properties that translate to out properties. Okay, and then I would use layer, which includes I think depth as well as the out properties, and then again the unique properties, right? So this structure right here, just by copying and pasting it and naming this one thing to match the class, seemed to save me a lot of time, and again made for a nice API going forward. I don't have to have multiple exported interfaces, coming out of this particular module, meaning the file. I basically have it be, properly coming out as a subclass. Essentially, these are sub interfaces of this class. So it's, again, really kind of a cool thing to do. And just to kind of show you one last example is the last one I'm working on is the conv layer. It's kind of big. You'll see that it's got a lot more unique properties, right? And it's got there's interesting is that the options takes filters, but the options is a number. What JSON passes back and forth is actually an array. So this was a way of kind of distinguishing. These are what's unique, and these are what's essentially different between the two. And everything, as you can see here with the green check mark, is pretty happy. We've got our conv layer JSON type, and we implement the unique values, plus it's also doing layer in because it needs to have these as well. So that's pretty much it. That's my happy Thanksgiving goodies for code for the holidays. I hope this helped everybody. I'm really, really hoping that people will give me some comments and feedback on this one, because I think it's something that is controversial for some, it's confusing for others, and then there's probably going to be somebody that's like, "You're full of it. That's so stupid. God, you shouldn't do that." And I want to hear all that stuff, because this is an experiment in some respects about trying out these different ways of doing things to make an API better, and I'll go and I'll consume it myself, and I find that the more time I spend refining it, the easier it is for me to consume. And that's the whole point, is to make it easy for you downstream of writing the code. The one thing too to kind of note, now just a reminder, is with these string literals, this is a very new thing, and it's not something that is available. I've never seen this in C#, for example, as a way of like constraining to strings. And it's to have it in JavaScript a big deal. So this is new to me. This is new, I think, to a lot of people. How do you properly structure this together in a way that makes sense for, kind of as a pattern? So I'm very hoping to get some criticism here from anybody, maybe even any kind of suggestions that maybe I'm missing about how to make it better. So yeah, that's pretty much it. Again, please give this video a like if this helped you, and maybe you can, like I said, comments, please. And if you want to see more content like this, subscribe, and we'll see you in the next video. Thanks.